Good evening, everyone. My name is Leah Miller. I am the oops, I knew my light was going to do that to me. Just a moment. All right, let's hit the reset. My name is Leah Miller. I'm the Outdoor Recreation Coordinator and Project Manager for the La Crosse River Marsh Restoration Project with the City of La Crosse Parks, Recreation, and Forestry Department. I'm so pleased to be co-hosting this webinar with Casey Meehan of Friends of the Marsh. And before we get started, I'd like to acknowledge the organization of the Friends of the Marsh, their president, Chuck Lee, members, John Sullivan and Karen Aker, for their dedication to the preservation and enhancement of the marsh and to this multi-year restoration project. It's really wonderful. There's still people joining, but it's really great to see such a great turnout for this webinar. And I think a lot of that is due to how every one of you is connected to the marsh, and your connection could be for transportation purposes, fitness, exercise, tranquility, or wildlife viewing, to name a few. But regardless of your connection, you're here because you care about the marsh in some way and you want to see it restored and maintained for future generations to come. Now, you may have already noticed, but we have disabled the unmute function on your screen in an effort to reduce interruption and distraction through the presentation. But please feel free to submit any questions throughout the presentation to the chat function at the bottom of your screen, and we will try to answer as many questions following the presentation that we can. This presentation is being recorded and will be uploaded to the Parks, Recreation, and Forestry and Friends of the Marsh web pages for later viewing. All questions will also be answered and posted to an FAQ to those web pages. I'll insert a link to the project pages in the chat once we get started, and I'd encourage you to visit those pages frequently to stay up to date on the project. This evening, we have prepared a 90-minute webinar session to review the first year of a multi-year restoration project to address hydrology, habitat, and recreational infrastructure. Dave Wilmot and his team of specialists have analyzed the historic marsh conditions, current conditions, and influences, and developed several options for design changes and cost estimates to systematically work towards restoring the La Crosse River Marsh. Now, I'd like to introduce Dave Wilmot, Principal Engineer for Smith Group and his team of specialists, who will be highlighting the first year analysis of the marsh hydrology, habitat, and trails. Dave, floor is yours.
Thanks, Leah. As Leah mentioned, we've been working with the city for the probably last year or so, looking at some of the existing marsh conditions, basically getting an understanding of what the issues are out there, and trying to carve a path forward for this long-term project. I think as Leah mentioned, this is basically year one of what we anticipate to be a pretty long-term effort to restore the marsh. Took 150 years for the marsh to get to the condition it's in, and unfortunately, we're not going to be able to turn it around overnight. But I think by the investment that the city has made in this, and you know, the interest of the friends and everything, we're definitely moving in the right direction. So the first slide here shows basically the team we've been working with. We've been working very closely with the stakeholder team consisting of Leah and her co-workers in the Parks and Recreation Department. We've been working very closely with the Friends of La Crosse Marsh, including Chuck and John and Karen and the rest of the crew. We've had representatives of city engineering, and our team has consisted of me. As Leah mentioned, I'm Dave Walmut. I'm the project manager. I'm a civil engineer, and one of my specialties issues has always been hydrology and hydraulics, so it's pretty been well suited to this project. And we've had a team of landscape architects and other civil engineers, and we're working with a firm that specializes in hydrology and marsh restoration and limnotech, and Craig Taylor will be presenting with me. So Craig, if you want to give a real quick introduction.
Yes, thanks. I'm Craig Taylor. I usually introduce myself as I'm just the guy who loves water. I've always grown up in riverine communities similar to La Crosse, and anything I can do to let the river be a river is my ambition. So thank you.
All right. So we're going to spend about the next probably 30 to 40 minutes giving kind of an overview of what we've done in the past year. Just a quick list of some of the things we're going to talk about. Initially, I think Craig's going to talk about some of the conditions and influences that what has formed what the marsh is now and what it's always wanted to be. We'll talk briefly through some of those conditions and the analysis that Craig has performed, and then I'll talk a little bit about our initial outline for conceptual improvements to the marsh. And then we'll wrap up with a question and answer session. And one thing that I do want to point out that you're probably going to see that you may notice is missing a little bit from this presentation is we're really going to be focusing on hydrology and hydraulics. And we recognize that a major part of what's been going on in the marsh is the loss of habitat, the invasive species, a lot of ecological things. One of the focuses initially is looking at the hydrology, because restoration of some of those other influences is not likely to be successful until we get the hydrology under control. So in consultation with the city and with the Friends, we all felt that the emphasis should be on hydrology in the first year. So that's what you're really going to hear us hitting on during this session. So I've got a little mosaic here that shows some of the issues that of note in the marsh, and I'm sure most of the users and people who are out there are very familiar with most of these issues. The persistent inundation, the marsh historically has wanted to be more of a traditional marsh with interim periods of wetness and wetland grasses and things like that. We've seen, especially over the last 5 to 10 years, that it's turned into more of an open water environment, which is much less conducive to a diversity of habitat and a number of other issues. We've seen an increasing number of trail closures. I think this is a photo I took when I was up there, I think on August 10th or 11th, and this has become far too common. We've seen the city's costs increasing substantially because of the washouts and the inundation that has occurred. I believe this is a photo of a washout on the Cottonwood Trail. A few other photos just with the emphasizing the continual flooding, the overflow of a couple of the trails, and we've also seen degradation of the drainage structures that are in there now. These have reached beyond their useful life and are going to need to be replaced in the near future. There are development pressures that we want to make sure the marsh is protected against. And of course, the ongoing issues with our friends, the beavers, which have been, slow down drainage and they're a natural feature, but they can be a nuisance sometimes. Some of the goals that we've talked about in moving forward with the project is we're striving to improve the hydrology so that the maximum water levels and the duration of flooding are reduced. As I mentioned, we want to reduce the annual maintenance costs associated with the repair of infrastructure. We want to reduce the frequency and duration of trail closures. And we want to stay with the Marsh's mission of providing education and interpretive opportunities. And I don't know if John Sullivan's on the line from Friends, but I do want to give him credit. He posts some great pictures on their website, and this is a photograph that I stole from him. So going back to the point I made earlier about our focus of this study is really on the hydrology, and basically what this graphic is showing, that everything having to do with the complexities of life in a marsh, the biology, the physiochemistry, the geomorphology of the rivers, everything else hinges on hydrology. Hydrology affects what plants grow, what habitat lives in the marsh, how everything functions. So it's really the foundation upon which everything else is built. So that is really what the emphasis of our study is here. So with that brief introduction, we want to get into it, and Craig's going to give a quick overview of just some background on what drives the marsh to be what it is.
Yeah, so as Dave has mentioned a number of times, really the first question we ask when we are looking at a site like this is, what does the river want to be? And then once we know what the river wants to be, we can try to understand how we can merge the river's needs in order to function with the community's needs in order to use it as an asset. So that starts typically by looking for reference sites. So here are a number of reference sites that we've just found within the region. The 5 Mile Bluff area is a great example, and really all of them have similar characteristics. They're all quite flat. Most of them have one dominant river channel through the center of them, but then they all have these secondary channels in which the water, you can see all these little interwoven channels throughout, in which it's very dynamic. The water and the sediments around these islands are constantly shifting, constantly in flux. They tend to be very green and luscious along the on all the uniquely shaped islands throughout the system. And this is called an anastomosing stream. It's not it's just a stream type. We would, the generic name for it is a braided stream, but we like the big fancy words. So next slide. Hey, Dave, can you scroll forward to the next slide, please? Thank you. So we've been working, just by looking at the reference streams around it, we developed this initial theory that the La Crosse Marsh and the La Crosse River in this area used to be this anastomosing stream form. And we discovered this map from 1888 in which they actually documented at least 3 different stream channels or river channels transecting the site. And so that's our first piece of information in our weight of evidence. And on this right hand side, this blue line is the layout of the river channels, the 3 river channels from 1888. And it's overlaid on our site, which this faint dashed white line is the single channel that's there today. And given the survey extents that were available in 1988, we can postulate that there are many smaller channels within the site that aren't showing on the map. Next slide, please. So by looking at some of the channel scars, every time a channel moves through a landscape, it leaves a scar on the surface. And by looking at some of the scar patterns, we believe that there were at least 3 different channels alignments through the marsh at some point in its history. And they've been forced into this single channel due to encroachments in the floodplain. So some of those encroachments are roadways rail lines, abandoned rail lines, trail crossings. There's also a natural encroachment in this red line, which is a natural levee. So the sediments from the river deposit on the banks here, and they create a natural high point, cutting the marsh off from the channel. Next slide. So once we consider what the river wants to be, we have to think about how we can facilitate that change. And this diagram identifies quite a few different marsh influencers and how we can manipulate them. Some are very difficult to manipulate and some are impossible to manipulate. Unfortunately, none of them are easy to manipulate. But that doesn't stop us from trying. We can still make good progress by understanding which ones are the most important. So stepping through those on the next slide. First of all, what's happening upstream in the watershed is a major manipulator, right? They are a major controller. So things like land use and soil types and just how steep the landscape is all influence the amount of water that's coming down the river during various flood events. Most of those are outside of our control. Next slide, please. Next is the Mississippi River. It's on the downstream end. There's the confluence. When the Mississippi River floods, it's going to back water up into the marsh, and there's really nothing we can do to control that, but we need to understand its impacts. Next slide. Third, we have the city of La Crosse, an urban landscape on both sides of the marsh. It generates urban stormwater and flows directly into the marsh. We do have the ability to manipulate some of those flows, and through a permitting process that the city of La Crosse has gone through called MS4, they've started taking the steps to control their stormwater and reduce runoff volumes into the marsh. So that is a great path forward. It will be effective in the long run. It will take time to implement though. Next slide. Next is climate change. Rainfall has been progressively increasing, and since 2013, the last 9 years or so, the rate of discharge in the La Crosse River has increased by an impressive amount. So that is partially due to climate change. It's also partially due to developments within the watershed. So some of those developments, by using good practices through the MS4 process, some of those flows can be mitigated, but the climate change flows, there's not much we can do about them. Next slide. Internal influences on the way the marsh performs. Topography is the obvious starting point. So the shape of the marsh, that's high points and there's low points, and where those exist have a great influence on the way floodwaters move through the system. We have almost infinite control over those, although it is rather expensive and labor intensive to move materials around in the marsh. So we do want to be aware of those options and use them where necessary, but be limited in our direct interventions to the landscape themselves. Next slide. Internal flow patterns, so how water moves around the site. As I mentioned before, it used to be, we believe the marsh used to be an anastomosing system, so water kind of found its own path through the marsh, and it's been cut off by various crossings. All of those crossings, when they were built, had culverts placed in them, so water can still move around the site in theory. Unfortunately, many of those culvert crossings have either become fouled with debris and sediment, or they simply weren't designed with anastomosing systems in mind. So next slide. So, and so here's a few examples of what these encroachments and crossings look like. And these are the easiest ones for us to manipulate and try to take steps towards restoring the marsh. Next slide. So on the hydraulic analysis side, we did some moderately sophisticated numeric modeling using a software developed by the Army Corps of Engineers called HEC-RAS. It allows us to run synthetic flood events through the marsh and see how the water moves through the marsh and where water may be trapped or isolated. We looked at two events. One was a small flood that occurred in 2007. It's about the size flood that you would see every other year or so. One was a moderate to large size flood that occurred in 2017. Next slide. So when we modeled the system, we found that it did a relatively good job of predicting when and where the trails would be overtopped. So there's an image on the left of the Grand Crossing Trail and this major spillway location that's repeatedly been washed out. That's the photo that was taken during the flood in 2017. The image on the right is an aerial photo of that spillway location, and the blue overlay on that is the flood extents around that time. And the general extents are lining up fairly well with what was observed. Next slide. And the biggest takeaway that we found from the modeling here is that what's happening to the floodwaters that overtop this natural levee where the red line is located is really a critical issue. So normally what would happen is water would flow over the levee. Oh, let me get in my drawing tool here. That would flow over the levee at the beginning of the storm, would flow to the west and back towards the Mississippi River. But unfortunately, it's being cut off by the trails with the block culverts. And so that water really has nowhere to go. So it's just staying here in a ponded form. And so, you know, pre-settlement conditions, we would have expected this waters that flood up into the marsh to have drained back out in about a week. And our simulations of the storms that are happening today, that water is hanging out for 3 to 4 weeks. So it is not only is it just hanging around longer and we're seeing more open water within the marsh, the extended flooding in the marsh is changing the habitat and vegetation palettes within throughout. So when Dave talks about at the beginning this functional lift pyramid saying restoring the hydrology is the first step to restoring the habitat and ecology, this is why, like, we could go back and replant a more desirable plant palette, but if they're just going to be flooded out and drowned, that would be a waste of money. So we'll start at the bottom of that functional lift pyramid, work our way up. And just for reference, that image that was on the lower left-hand side there is what some of these numeric model results look like. And then the next slide, this is really just a summary of the things that I already mentioned, but the most important takeaway on this slide is the second bullet that identifies that we believe that without having to go through and remove all the obstructions, that we can get those drawdown times back within that 1 week time period that existed in the pre-settlement condition, just with some smaller manipulations of the crossings and not going through a full-blown expensive and intensive restoration throughout the site. So, and then Dave will talk about paths forward.
All right, thanks, Craig. Before I move forward, Leah, I don't know if there were any questions that came in on that preliminary overview before I get into the plan development part.
I think we are good to continue. But again, if anyone has questions, please feel free to drop them into the chat for myself or Casey, and we'll be sure to address those following the presentation. Thanks.
All right. Thanks, Leah. I'm working from 3 screens here, so I'm jumping all over the place, so my apologies. But anyway, thank you, Craig. So that was basically the analysis that Craig just went through is kind of how we spent probably the first 5 or 6 months of the project, just trying to understand how the marsh functioned so we could, understand what the issues are to lay the groundwork for, preparing our framework plan for restoration. So what I'm showing on this first slide is kind of a geographical overlay of where we found some of the primary issues and some of the areas of concern. I guess first and foremost, like Craig mentioned, the waterway opening restrictions that we see below Lang Drive, below the Grand Crossing Trail, below the Cottonwood Trail. And one quick caveat, I just learned from Leah this afternoon that the naming of the trails is fairly new. So a lot of the trail users, you may or may not be familiar with the names of the trails, but Lang Drive, I'm sure everybody knows where that is. The Grand Crossing Trail, when I refer to that, it's the trail that comes off of East Avenue, runs basically north up near River Valley Road. The Cottonwood Trail is the trail that starts near Myrick Park and kind of winds around. And then the Willow Trail is the trail that basically starts from the intersection, I guess at about the midpoint of the Grand Crossing Trail and runs, basically east-west. So, and I have those labeled a little farther on. And if I'm not clear on that, feel free to shoot something in the chat, and I'll try and clarify that. But anyway, as far as where we see a lot of those constrictions, where along Lang Drive, the blockages along the Grand Crossing Trail and the Cottonwood Trail. We see frequent washouts along the Willow Trail, especially near where the river bend is. We're seeing some abutment because of the natural migration that the river wants to take. As Craig mentioned, it's starting to threaten the abutment along the north side of the Grand Crossing Trail bridge over the river. And we understand that there used to be a much better defined trail linking Red Cloud Park and the Grand Crossing Trail, which is rarely accessible now because of high water and because of failure of the footbridge. A couple of the other big issues that we've been looking at is the former gun club site is, I think the city is being required to do some remediation of the lead, and the path forward has not been completely defined yet, but that will certainly define what happens along the Grand Crossing Trail in the future. One other issue, kind of a La Crosse infrastructure issue, is there's a major water main that runs right below the Grand Crossing Trail that serves neighborhoods to the south and north of the marsh itself. And that's a critical piece of infrastructure that needs to be protected. And just in the context of, as we're looking at the marsh, making sure that that is accessible and not damaged, and is a resource moving forward. Some of the constraints, whenever we look at a project like this, we need to understand what the opportunities and what is going to impact our ability to do the things we want to do out there. In the case of the marsh, one of the big things is it's a wetland. Construction of anything in a wetland is very sensitive, requires a great deal of permitting, a great deal of interaction with regulatory agencies such as DNR and the Corps of Engineers. Now, anything that we do in the marsh, our goal is to enhance the marsh. So I think there's a lot of opportunity to work with the regulatory agencies, but regardless, there are a lot of hoops that have to jump through. So anything we can do to minimize those impacts is beneficial. I mentioned the water main. That's, and I'll get into this in a little more detail later, that's a huge item that we have to consider when we're looking at any improvements, especially along the Grand Crossing Trail. There's also a piece that goes under the route of the Red Cloud Trail, so we need to look at that. The entire area is in the floodplain and floodway of the La Crosse River itself. Basically, the floodplain area is defined as the area that is inundated during a 100-year storm on the river. The floodway is, without getting into a lot of detail on it, it's the area that carries most of the water, but it's much more highly regulated even than the floodplain. So anything we do within these areas, we need to be able to demonstrate that we're not increasing the flood elevation. So it may limit the amount of, for instance, in a perfect world, it'd be nice to be able to raise these trails above the level of the 100-year flood elevation altogether. But because of potentially the fill that would be needed to achieve that, it could cause an actual increase in the upstream high water level. So we need to balance those impacts with the beneficial impacts of raising the trail. I don't really have this shown graphically on here, but throughout the marsh, there are a number of parcels that are either privately owned. And Leah, feel free to correct me, but I believe there's a large area in the north here that is privately owned. There is a utility easement that runs basically through the middle of the marsh and north-south through the marsh. Lang Drive is under the jurisdiction of the Wisconsin Department of Transportation. So anything we would do regarding Lang Drive would have to be done cooperatively with the Department of Transportation. And anything we do in the marsh, it's a very constricted area, so we're going to have challenges with construction access. So none of those say we can't do it. They don't prevent us necessarily from doing anything, and we're not going to throw up our hands and say we can't do this, but these are things that we do need to understand as we're budgeting these and looking at what the most appropriate improvement is as we move forward. So just some of the real big picture long-term objectives, and I think I've kind of touched on this, but we want to improve the trail and the water main resilience. We want to improve those north-south connections, and we want to reestablish a flow route or improve drainage through the marsh. And I'm referring to this as reestablishing Silver Creek. There is some flexibility. I don't know that we would establish what existed there in the 1800s, but the southern portion of the marsh, generally north of Myrick Park, and kind of through a corridor like this, is basically the topographically lowest point. So if we can improve the drainage through the lower portions, it's going to it's going to help lower the water level, or at least lower the duration of ponding throughout the marsh. So this is kind of a target area that we're looking at for drawing water down. So with that in mind, once again, talking about our general path to improvements, Craig talked about the former Silver Creek route coming through. He talked about the idea that there are certain interventions that we can take affecting topography. The most logical places to implement those interventions are at these existing embankment areas. It doesn't make a lot of sense to get into the middle of the marsh. It'd be very challenging and very impactful to try and excavate in the middle of the marsh. So it probably doesn't make sense to do much, but there is a focus we can make. So big picture, some of the initial projects we're looking at have to do with improving marsh drainage through these embankments, with the goal of initially, creating some openings in these areas so that over time, when we get a more positive flow pattern, the idea is that we could reestablish more of a flow pattern through these. So, trying to restore these areas to more of a less of an open water environment and more of a natural marsh condition. So now I'm gonna kind of transition into some of the specific measures that we've been looking at. And Leah, I'll stop once more just to see if anybody did have any questions as I'm moving forward.
We've got a few coming in, but I think I'm going to save them till the end. But
Okay.
keep them coming.
Okay, that's fine. Okay, so anyway, I want to talk about some of the specific practices or some of the specific ways that we go about trying to enhance access while minimizing our footprint on the marsh and helping enhance drainage. The first I guess piece of infrastructure that most people are likely familiar with in marsh environments are boardwalks. And a boardwalk is generally, I guess the traditional one is basically a treated wood deck that's built on piers of some sort. So the idea, I've got some photographs here on the right-hand side of a project we did a few years ago in Clarksville, Tennessee. But as you can see, the idea is to kind of elevate the walkway above the marsh elevation. This is the piece that was under construction. It provides some area for water to flow beneath it, elevates the pond so it's not perpetually flooded, and it takes up a minimal amount of footprint. Unlike a path that's built on a traditional embankment, you don't have the fill that extends out from the boardwalk. So you're not impacting the resources that you're trying to protect as much. One of the challenges with a boardwalk like this in the environment we're looking at is it's unlikely that we're going to be able to elevate any of these features to the extent that we would like, so they're never going to be prone to flooding. It's in a 100-year floodplain. These are still going to be prone to getting wet and drying, and the lifespan of a traditional wood boardwalk is somewhat limited in that environment. The decking may last 10 to 15 years. The supports, if the piers are built properly, it's going to last a lot longer than that, but the decking is always going to be subject to those issues. An alternative to a boardwalk such as that it's a traditional boardwalk, but and this is a proprietary system called Permatrack. There's other systems that are similar, but rather than being a wood boardwalk, each of these pieces are built of precast concrete. So they're much more durable. They can withstand a higher load. They're quite a bit more expensive. A traditional wood boardwalk is $175 to $200 a foot. A Permatrack boardwalk is quite a bit more expensive, but on the flip side, this may have a longevity of more like 50 to 75 years. It's also easier for snow removal than a traditional wood boardwalk. It can carry a higher load. So in a situation such as when we're trying to access the water main, you can bring in more equipment or heavier equipment and things like that. So I think one of the conversations we had with the friends in the city, and my personal preference is I like the look of a traditional wood boardwalk much better, but we're looking at pragmatism along with what works the best. So anyway, this is another approach that we've looked at. A third approach is accepting that portions of the trail are going to wash out periodically. We're not necessarily going to be able to, this approach would not necessarily raise the flood elevation or the overtopping elevation any more than it is, but what it would do would be save the city quite a bit of money down the line. Anyway, what I'm calling this a hardened trail concept. And what this is the existing embankment that the trail's built on more, but it has a concrete cutoff wall and a hardened concrete section on the upstream and downstream side. And what that does is, for instance, if you recall the photograph I had shown previously with water flowing over the spillway, you can see that there's quite a bit of velocity going over the top. And what that wants to do is it starts to wear away at the downstream side of the embankment, starts to erode, and then it basically washes out the culverts and everything else that's underneath. By putting this cutoff wall in, making this a more hardened surface, and putting vegetated stone or riprap, it's still going to overtop, but the city's not going to have to spend $10,000 and a lot of crew time every time it washes out. So there's benefits and disadvantages. This is just showing a kind of a similar application. This is up at Saxon Harbor, which experienced a pretty devastating flood a few years ago. And this is just an engineering detail showing a similar overflow route. In that case, we had a stream that came through that was prone to flooding once every couple of years. And rather than blowing out the entire embankment, this concrete spillway was constructed with a cutoff wall to prevent that from happening. And it's been very successful. And then another type of section that I think most people are probably familiar with is just a traditional culvert. And basically it's a tube or a concrete tube or a metal tube, or basically an opening through the embankment that allows water to flow from one side to the other. And there are a number of culverts under the trails now. The problem is, in many cases, they're not set at the right elevation. They're blocked on the upstream and or downstream end, or they're sized too small. So there are a number of areas where just a culvert replacement or something along those lines is appropriate. One of the challenges that we'll talk about a little bit, especially along the Grand Crossing Trail, is this little circle in here represents a water main, and that water main is running right where we would ideally want that pipe to be. So we're going to need to, options include either relocating that water main, which gets very expensive, or placing the culvert at the proper elevation to facilitate drainage through there. So those are kind of the building blocks of some of the projects that we were talking about. Now just trying to, or kind of honing in a little bit on some of the more detailed ideas that we were looking at. And I'm not going to go through, I'll get to most of these alternatives here as we're going through it, but my intent is not right now to describe every single one of these alternatives, but kind of describe the process that we went through. So I think probably starting in June with the group, we started talking about some ideas for some general improvements. And basically what we initially divided these into were tier 1, tier 2, and tier 3 projects. And the tiers were kind of identified based on what we felt, first of all, would give us the most bang for the buck, and what would have the fewest number of complications. For example, the blue line, I guess this looks like kind of an inverted cactus, but this is along the Grand Crossing Trail. And the idea was we felt we could get the most bang for our buck initially by looking at culvert improvements, spillway improvements, or other improvements along that trail itself, since it is kind of the main hub. That's not to downplay the importance of the work at the Cottonwood Trail or along Lang Drive. Lang Drive was identified as a tier 2 rather than a tier 1 because we feel it's likely that any improvements of Lang Drive are going to have to be implemented in conjunction with future improvements that DOT will have planned in there. So there's going to be an interim step, probably a long interim step, where we meet with DOT, talk about what their plans are, when Lang Drive is slated for improvement, and collaboratively work with them to see what can be done to help achieve our marsh goals in there. Tier 3 is identified as a lower tier because we do not feel there's a benefit in implementing improvements in this area as long as the lead remediation program is still being developed and understood. One of the things we've talked about is maybe can we use the lead remediation project as a tool for implementing some of the improvements that we hope to achieve through here. Those discussions have not started yet, but anyway, from the standpoint of how we're approaching this, that's why this is a little lower tier, because we don't believe that's something that should happen until that issue gets resolved. And I'm not going to go through all this, but this just is a matrix that we put together and presented to the group initially as kind of a talking point. Basically, we developed a number of these alternatives for some of the different areas and did kind of a somewhat quantitative, not overly scientific, but just kind of applied a scoring system to some of the challenges, meaning, you know, if a project would involve more floodplain and floodway fill than another project, it scored lower as an example. And then we looked at that also from the standpoint of benefits. A project that may be more conducive to outside funding, for example, was given a higher score than one that may not. So anyway, we weighed these all together, and this was not the decision matrix itself that we used to prioritize project, but it was kind of a tool that we used for discussion with the group. So with that, I'm going to go into a little bit more detail on some of the specific projects that that we arrived at. And once again, I want to caveat this, that this is a high level kind of framework master plan at this point. We have not done any detailed design. It's a long ways to go on this, but the goal here was to try and identify where we should focus our efforts and where we should start moving forward. So the first location here is at the Grand Crossing Trail. Once again, the Grand Crossing Trail is basically the trail that runs from East Avenue, runs northward, just about to River Valley Road. It's kind of the one of the main links from probably from campus to the State Trail farther to the north, and to the Willow Trail and everything else going east-west. But anyway, the first project in here was is at the spillway itself. And if you're not familiar with the spillway, when you're probably about to the midpoint, there's a little dip in the trail itself that's probably 1.5 feet or 2 feet lower than any of the adjacent areas. And the intent of that spillway is to allow very high flows to convey from east to west across it. And this is a photograph of what happens during those large storm events. I think there have been a number of attempts to pave this section or harden this section in a way that will allow that water to flow without causing damage. But the challenge is it's been a source of a lot of expense to the city because it always washes out. So it's considered a very high priority item. A couple of the alternatives that we looked at, first one was a boardwalk section. So the idea here, once again, is we would basically span that low spot with a boardwalk. The idea would be it would maintain some opening below the boardwalk itself to convey water, but presumably because we would be raising the elevation a little bit, it would drain better. It also would raise us from maybe being shut down every year on an annual basis for maybe a 2 to 5 year frequency of being shut down. It still does not address the 100-year, but it would, along with the hydrology improvements, really help the serviceability of that area quite a bit. One of the challenges involved in this would be, as I mentioned, the presence of the water main. It's basically right where we would ideally like that opening to be. Ideally, we would bring this opening down a little bit lower, but we need to maintain a certain amount of cover and protect the water main from freezing. So it does limit what we can do. But anyway, that's kind of what the general idea would be here. This is showing this as a wood boardwalk. I think in our discussions, even though it would be a higher initial expense, I think if we went with a boardwalk in here, the preferred approach would be with a permatrack or a precast concrete. Once again, the main reason is we need to maintain access to the water main, and a permatrack approach would be, it'd be more resistant to the heavy loading of the equipment.
Dave, we've got a question kind of along those lines.
Sure.
I think it'd be appropriate to address it now. And the question is recycled plastic or other materials that are less prone to degradation another option for a boardwalk surface? What is the cost difference and durability? Is that something you might be able to?
Yep, very good question. And we have used, we've used those in other circumstances. There's composite materials that there are a lot of boardwalks made out of. They are more durable than wood. I would guess they're probably double the lifespan of a traditional treated wood boardwalk. They're still probably only maybe a third of the lifespan of a precast concrete boardwalk. They are still prone to more maintenance than precast concrete. Oh, I just lost my lights too. I'm in the same boat as you, Leah. Sorry. Anyway, they're prone to, because they're exposed to sunlight, they do tend to be prone to cupping and some things like that, and they can be a little slicker than concrete or wood. But it is definitely an option, and I think they're becoming more prominent. So it's something that's definitely worth weighing with some of the other solutions that we're looking at. So great question. Any others, or should I keep going?
Let's see. We've got another one. I'm not sure if we'll be able to really answer this one completely, but how does the sustainability of sourcing materials compare between traditional wood, boardwalk, and concrete?
That's a good question. Actually, that's a really good question. I'm not going to have a good answer. I can just throw out a few thoughts. I think like traditional treated wood, I think a lot of that is southern pine. I wish I had one of my landscape architects on board. They could probably answer that closely. So it's wood sounds great, but it may be shipped from quite a distance. Likewise, precast concrete, you could make an argument that it could be made locally, but proprietary product, that material is probably coming from quite a ways away. And I'm not real sure about where the composite would come from. But I think that's a really good comment and a good thing that should be considered as we're moving forward. And I apologize for not having a better answer, but anyway, but if we write it down, I can actually bounce that off some of our landscape architects that I think are probably a little bit more in tune with that.
Sounds good. And just a reminder to everyone, if there are questions that come through that we can't answer, we'll find those answers out as best as we can and upload them in an FAQ document to our web pages. But keep those questions coming.
Sounds good. All right. So the second approach that we looked at to the Grand Crossing Trail is, once again, the hardened trail idea. Once again, having the cutoff walls, in this case, because the water likes to flow both directions over the trail, we would probably have cutoff walls on both sides. We'd have a hardened, probably a concrete surface at the spillway, and we'd be placing stone to better protect from the scour. And as I mentioned kind of in the introduction, in this case, rather than raising the trail 1.5 feet or 2 feet, it would stay at the same grade as it is now. So this would not help necessarily the trail stay open more than it does now as a standalone project, but it would be very beneficial in that once the water goes down, the likelihood of it washing away the culverts in the path and having to be repaired would be greatly reduced. It also does protect, one of the things we've talked about a little bit from an infrastructure standpoint is every time this trail fails, there is some risk of damage to that water main. And that water main, I don't want to speak for the water utility, but I don't believe there's a lot of redundancy in it right now. So there would be issues if there were failure of this water main. So it's important to protect the water main as well. Okay, second location I just wanted to touch on briefly that we became aware of, I guess, as being an issue is at the Grand Crossing Trail bridge over the La Crosse River. Basically, I don't have the greatest pictures of it, but this photograph, I'm standing basically the intersection of the Willow Trail and Grand Crossing Trail looking north, so you can see the bridge. You can see our team walking over the bridge in the rain when we were doing our field review. But the issue here is there's a very sharp bend in the river just upstream from that bridge. And to Craig's point about the river wanting to migrate, it wants to migrate to the north. So it's been slowly eroding in this direction. And it's really been starting to undermine the north abutment of the bridge. And so there's some need for that to be attended to sooner rather than later. This is kind of a blow up showing a solution that we would recommend in here. So this is once again showing the bridge coming across here. That abutment basically sits, I think you can see my cursor there where that's going. And as you can see, the river has actually eroded out into this area, and it's trying to work its way behind the abutment. The traditional way of protecting an abutment such as this would be to dump a lot of stone right along the bank, and that is certainly an option, probably the lowest cost option for protecting the abutment. There are other ways that are a little bit sometimes more ecologically friendly. If we just dump stone in here, for every action there's a reaction, so it's going to tend to want to force the water more into the other bend on the downstream side. So another solution that is sometimes looked at is a softer solution that consists of natural materials such as root wads. So these are basically tree roots that are shoved in with some stone, but also rather than lining the banks with stone, putting veins, and these are a little exaggerated, they wouldn't go this far into the river, but the veins tend to want to redirect the lower flows away from the abutment. And it's been a kind of a proven stabilization approach for, I don't know, probably the last 20 or 30 years. And another alternative worth looking at here. Craig, I don't know if you want to add anything to that discussion. Don't let me put the pressure on you, but
no, I think that does answer it quite well. This idea of the veins, it's really about redirecting the most erosive flows away from the bank. So there's a lot of energy there that's capable of picking up the sediments, and the veins will move that energy away from the bed and towards the middle. And downstream, the second set where the second set of veins are, there are ongoing erosion issues there that are being caused by the erosion and the constriction around the bridge. So
yeah,
if we do nothing and just line it with riprap in a traditional method, we really are just moving the problem, as Dave mentioned.
Yep. Thanks, Craig. So that brings us to the Willow Trail. Once again, the Willow Trail is basically the link from the Grand Crossing Trail on the east, and really is the main link ultimately to the Vietnam Veterans Trail and down, ultimately downstream. And this segment is, everything from downtown all the way along the trail and all the way up north. This is really the main commuter route from the state trail to the north to downtown. So it's not only a recreational path, it's used for commuting and everything else. And so it is a pretty major area. One of the challenges here, there are a number of challenges. This is a photograph that was taken, I don't want to say during a dry period, but it was definitely not during a flooding period. I think it was in May, but you can see basically the trail doesn't drain well, even when it's not flooded. But the other issue is we are also near the outside of a stream bed, and the river is trying to migrate to the west. So, I'm sorry, to the south. So, it is at risk of being washed out, and it is frequently out of service for an extended period of time due to flooding. So it was considered a kind of high priority area. So a few of the solutions that we looked at, once again, these are the veins that Craig was just referring to as a way to supplement the riprap. And in a perfect world, we would allow the river to just follow its natural migration patterns. The challenge in this case is the proximity to the trail as it sits right now, and the fact that it's going to keep moving to the south. So is in as sensitive of a way as we want to. We would like to redirect the water away from it to minimize the migration to the south. In this option, as far as the trail, what we're looking at is a raised boardwalk. Once again, if you're familiar with the trail through this area, the intersection with the Grand Crossing Trail is probably a couple feet lower than the lowest portion of the trail through this reach. So under this scenario, we would basically be leveling out the trail with the boardwalk through this reach to allow it to raise up and allow some area for water to flow underneath when the La Crosse River comes out of its banks. That would potentially raise the level of service of the boardwalk from probably a 1 or 2 year period where it gets washed out now, not to mention the poor drainage, to maybe closer to a 5 or 10 year. Once again, it's in a floodplain and it would be prone to periodic washout, but this is a way to improve the resiliency. So that was one option we looked at there. The second option is just move the trail. Once again, this would be a raised boardwalk, but look at relocating the trail farther to the south. There are a number of regulatory challenges with this. This would be nice to give it a little more of a factor of safety from the river migration itself, but there would be a pretty substantial amount of wetland disturbance moving it to the south. And I don't know, this is something we'd have to discuss with the regulatory agencies if this could be allowable in some way, but this was another option that we looked at anyway.
And to be clear, when we mention washout in this scenario, we're talking about flood inundation over the top of the trail and not structural damage to it. It'll be designed to withstand over time. So.
Yeah, that's a good distinction, Craig. This would be designed with a footing, calculations to make sure that the things like the uplift from flooding water would not damage the lateral pressures from the water impounding on the side could be withstood. But yeah, when I say washout, it would mean it would be over top, not washed away. Another location that we looked at and is at, I guess, on the very south end of the Grand Crossing Trail. And this is basically at the crossing of the old Silver Creek, one of the former drainage ways that came through here. Just a couple photo references. If you're familiar with it, this is that small trailhead that is just at the north end of East Avenue. And then this is looking farther north along the Grand Crossing Trail, just to get you in the ballpark there. But this I think, in my opinion, is one of the, from a hydrologic standpoint, is one of the key areas that would be worthwhile to look at. I think historically, once again, the water main crosses under the south, but historically there was an old railroad trestle that crossed for years up until, oh boy, I would probably have to defer to one of the friends of or one of the old timers out there, but my understanding is probably back in the early 70s or mid 70s that was replaced. And when the water main was constructed, the trestle was replaced with a couple of very small 24-inch culverts that cross under here that are pretty much completely buried now. So this is a source of substantial blockage of and probably one of the sources that causes the east cell to have standing water for an extended duration. So the idea here, the simplest idea here would simply be replace the existing buried 24-inch culverts with a larger culvert. And one of the ideas that we looked at would be like a 12-foot arch culvert. It's once again, it's complicated by the fact that the water main is running through that area. So we would have to strike the right balance of getting the culvert at the correct location to allow the water to drain, probably doing some grading on either side of the embankment to daylight the culvert to make sure it could positively drain, and also providing adequate protection to the water main through insulation or other measures so we don't damage it. Or alternatively, once again, in a perfect world, we would relocate that water main so we have a little more flexibility, but relocating a 24-inch water main is not an inexpensive item. So that's one of those things we would have to look at more closely as we're getting into more detailed design. So this solution is very beneficial in reducing the duration of ponding throughout that portion of the marsh. But like I said, there are some other challenges involved in it. Kind of a more grand concept that we looked at, and this was, and I'll get into some of the reasons for this, but this would be a little bit more of a, I guess, multifaceted project. First of all, as you can see here, the idea would be reestablishing kind of the historical pattern of flow in the old Silver Creek corridor in here. The other item or thought that we looked at here is that north end of East Avenue is a pretty major meeting spot and a kind of a gateway to the marsh itself, but it's not, real well marked out. And this may be an opportunity to put something like an interpretive area here. It'd be an ideal area to have some signage or some storytelling about the old history of Silver Creek and how the marsh got to be what it is. It could be an interesting place, kind of an adjunct of the Myrick Center. Have a meeting area for people to meet here, and it could be kind of an interesting feature. And I guess part of the reason we introduced a concept like this, recognizing it's not cheap by any stretch of the imagination. Sometimes funding agencies or donors or other people that may be able to contribute that have an interest in this, are much more interested in funding a project like this that's visible, rather than, it's not too exciting having a culvert named after you or something like that. But certainly a culvert or the hydrologic goals could be incorporated with a project like this. So anyway, this is just kind of maybe a little more of an out of the box approach to an area like this. This is also something that could be considered, when the Cottonwood Trail at the Myrick Center is upgraded as well. There's parking there, and it's a little closer to the Myrick Center, so that's another opportunity. But just as we're developing these solutions, we're looking at things technically, but we're also trying to look at things that will enhance the mission of the marsh itself, and also make them maybe more desirable for funding. So I think the last area that I was going to talk about is the Red Cloud Trail. Red Cloud Trail is the old trail that links just north of the bridge over the La Crosse River to Red Cloud Park and, you know, the neighborhood up in this area. And I didn't have any real good pictures. This is kind of looking off into the woods in that general area. But the main issue there is this used to be a fairly prominent seasonal connection between the park and the trail. And because of the perennially high water and the poor condition of the stream crossing in here, it's rarely accessible anymore. And this project the idea would be to reestablish that connection so it's more usable for a longer period of time in here. And just a couple of ideas we put together. This first alternative, once again, this would be kind of a combination of a paved trail, a boardwalk section, and a improved pedestrian crossing that would somewhat reestablish the link between the trail and Red Cloud Park. This would not, I think the current trail does not provide ADA accessibility or anything like that. So this is kind of the basics of what we would need to do to reestablish that trail. A second option that we looked at that's a little bit more elaborate would combine, you know, a paved trail with a new pedestrian crossing, and then provide ADA accessibility up to the park and maybe some sort of a plaza with an overlook. And once again, this goes quite a bit beyond the mission of hydrologic improvement, but from the standpoint of placemaking and possible donor opportunities and a way to, you know, just to have a vision for something in the future. This was a kind of an alternative that we put together. A couple of other longer term projects, and I touched on this previously. I don't want to forget about the necessary improvements to Lang Drive or the Cottonwood Trail. We didn't develop specific alternatives right now for these because they are so contingent on you know, other issues, but these are longer term projects that will continue to be studied as we move forward. Quick idea of costs, and these are very order of magnitude. As you probably gathered from my presentation, there are design issues such as how the water main is resolved, the materials that we use, the funding that becomes available either through grant projects or other sources. So I'm giving kind of a low and a high version of this. For instance, the low version, I'm really generalizing of each of these is, for instance, at the Grand Crossing Trail, the low would consist of probably just a rudimentary concrete spillway to, you know, improve the resilience. The higher cost would be more of a bridge or a, you know, a permatrack boardwalk. So there's a huge range, but I think the main takeaway from this is just for these initial tier 1 projects to implement this, it's, you know, we're talking multi-million-dollar range, you know, probably $4 to $6 million to start this out. So this is not a small endeavor by any stretch of the imagination. The flip side of this is when you consider that the city is presently spending, and Leah, you can correct me if I misinterpret this, but, you know, probably $10,000 after every flood or every major flood, and it's happening a few times a year for repairs, maintenance, and everything else. You can see that even though it's a large expenditure, if you look 25 to 50 years down the line, it's not such a large expenditure. So, you know, these costs, once again, will be developed a little bit further, but the idea was just to provide an order of magnitude of what some of these improvements may cost. And I'll just wrap up real quick. I want to leave some time for questions here. I'm going back to the goals that we discussed early in the presentation, and just some general recommendations. The report that we did has probably 25 specific recommendations, so I'm lumping a lot of these together in the interest of generalization in time. But, you know, our initial goal, we talked about improving the hydrology such that maximum water level and duration of inundation are reduced. Our general recommendation, this covers across many projects, strategically reestablish those hydraulic connections through the man-made embankments to improve the post-flood drainage. So basically, kind of prescribed interventions, I would call them. As far as reducing the annual maintenance costs, the idea is replace those key low trail sections at a minimum with more resilient boardwalks or spillway sections that are made of concrete that even if they flood, they're not going to fail, and they're not going to cause the city expend a lot of resources to repair. Once again, reducing the frequency and duration of trail closures, establishing those hydraulic connections, and ideally boardwalks where we can raise the elevations a little bit are ideal. And then increase the education and interpretive opportunities, pairing some of these engineering improvements that we talked about with recreational, educational, and interpretive opportunities wherever we can. Some other kind of more near-term recommendations in the report is with this report, I think the city now has kind of a initial framework. And I think next year it would make sense to start meeting with DNR, Corps of Engineers, and some of these regulatory agencies and start talking about some of these specific goals, getting some idea of what funding assistance may be available, what regulatory hurdles we would have to go through. Would not, a lot of these projects I don't think would be a kind of a routine regulatory process. It's more of a cooperative restoration process. And the earlier we start those discussions and express interest, the more we're in line for favor, I guess, financially and everything else. Second item, initiate discussions with WISDOT regarding those Lang Drive improvements. Talk about their time frames and what cooperative approaches towards implementing improvements could happen. I know the DOT often gets blamed for some of their maybe past misdeeds, and but there is money, especially with the infrastructure bill. They are falling under some of the same mandates to improve the environment as much as they can, and maybe there's a cooperative opportunity here. And I think the third item is start aggressively pursuing funding through state and federal grants or through potential donors. With all of the other local responsibilities, even though the city has funded these initial projects, there's a long ways to go, and there's no way these can all be built strictly from taxpayer funds or funds from the city. The best way to spend the city's funds may be to leverage those as a cost share for other funds. If we can turn $100,000 into $800,000, it's definitely worth pursuing. So I think that should be a real focus moving forward. So that concludes my long presentation, and I'm running out of voice, so I'd be glad to hear any questions that anybody else has.
All right, we've got a lot of questions, and I know we won't get to everybody, but we will post these. If you give us a couple of days following the session, we will post them online. But the first question is a big question, but how long do you think it will take for the whole marsh restoration? And I have my idea of what it will take, but I'm always optimistic that we'll be able to secure funding for projects, especially with we have some great community support. If you're still on this call tonight, we appreciate that. But Dave did mention some things that we'll face as we start to look more deeply at each of these projects. That is the obvious funding piece to it, permitting, and we touched on some of our top projects. There's still more projects that we're looking at, and there's still some segments of the marsh that are north of this central area that are to be added in future years of planning. So I don't know my exact answer. as far as how long I think it will take, but I'll be optimistic that we'll be able to start moving on some of these projects in the near future. Dave, you want to throw a number on it, or Craig?
Well, if somebody wrote out a check for $10 million, you know, I mean, hypothetically, if somebody wrote a check for $10 million, it would be, and we could turn around designing all of these features right away, just understanding the complexities involved in this and the regulatory process. And I'm not saying this is 2 or 3 years, but it would be a minimum of 2 or 3 years, even if all the funding was there and everything else, just the time to design, to go through the regulatory process and everything else. But realistically, between funding and everything else, it's implementing the improvements. Yeah, I would say it's a minimum of 10 to 15 years at least. And then that doesn't restore the marsh overnight. You know, it may help the hydrology. There's always going to be challenges with invasive species, and there's going to have to be a whole other set of interventions when the hydrology is resolved to improve those. So this is, you know, it took what we're probably talking 150 years to get the marsh to where it is now. We're not going to turn it around overnight, but you have to start at some point. And, you know, it was 30 years ago when the Cuyahoga River caught fire, or what, 30 or 40 years, and they've made great strides in that time, but it didn't happen overnight. So it's a long process.
And I think we should reiterate the strategy here is we would like to set the framework to quote unquote set the river free and give it the space to start healing itself.
All right, now our next one here, I think is more probably geared towards Craig. But the question is, how will you model or anticipate the impact of new stormwater plans by the city, and in parentheses, the Losey Boulevard area? And we are aware that there are going to be some changes through working with the engineering department. But Craig, will you be able to model what some of those impacts might look like?
Yeah, absolutely. Our modeling efforts that are coming, the more detailed ones that are coming down the road, will include a fully developed condition throughout the city. And so the total runoff volumes and those flows will be understood. The exact point locations may not be well resolved, but when we're looking at the entire marsh scale, we don't necessarily need them to be.
Thanks. And that might be another one for you. If you are successful in increasing the flow through the marsh and Silver Creek, how will that affect the flow of the river downstream of the confluence with the La Crosse River?
In effect, it should be negligible. The confluence really shouldn't feel that difference too much. The total flow coming in from upstream of the marsh and the total flow going out through the marsh will not change substantially through this effort. The drawdown time will be a little bit faster, so the flow immediately after a storm may be slightly higher, but the peak flow that causes all the flooding, based on the assessments we've done so far, isn't expected to change.
Yeah, I think that's probably an important thing to say. When we're talking about improving marsh drainage, you know, through some of these openings, it's still a relatively very slow drainage process. And by very slow, you know, it's many days, maybe a week or a couple weeks. But when you consider right now, it's many weeks, or if it drains at all. it's a big difference. We're not trying to create a situation where the water is coming in and going out right away. That's not going to happen. It's just a matter of reducing the period of time where we have perennially standing water.
Another question, and that was kind of answered, I think, briefly, but I think it's valuable to reiterate, is would this be less expensive, like the restoration, than all the repairs? And as Dave alluded to earlier, the cost of repairs that the Parks Department puts into maintaining these trails following a washout, it's frequent, and really in the last several years, it's happened several times. So that cost can, as Dave mentioned, be anywhere from $5,000, $10,000, $15,000 to repair those trails each time. And so much of that time is also spent while the trail is underwater. So the trail is really closed for sometimes 30 days. That's quite an inconvenience in itself. And then let alone the amount of time it does take us to make those repairs, because we just can't do those overnight. Where if we had some infrastructure that was more resilient, as was described in the presentation, we'd be able to get in there and clear any debris that may have gotten dammed up in a more efficient manner, reduce our costs. The cost up front is big, but we do see a lot of value in that paying off over the at least 50 years lifespan we would have with some of these improvements.
I think the other thing that's important to add is that this is not a luxury necessarily. You know, I mean, you could probably view this from a lens of, well, this is just to restore some trails or something. We have much bigger priorities in the city of La Crosse. The fact is, I think you probably saw some of the pictures earlier on of the culvert that was completely rusted out of the bottom. The fact that we have a 25 to 30-year-old critical water main that's going through the Grand Crossing Trail right through the middle of the marsh. You know, the fact that a lot of those trails are used for commuting, you know, maybe not in February, although if it's like Madison here, there's probably people that use it then quite a bit. You know, this is not strictly a recreational project or an ecological project we're talking about. It's like everywhere else that in the country right now, it's old infrastructure that serves a critical function, that there's going to be a cost involved in it regardless, and it's going to be a fairly high cost.
And if we think back to that climate change plot that we showed, where the flows have been increasing steadily since 2013, climate change predictions are projecting that will continue to increase. So the incidence of flood events is expected to rise. And if we do nothing, the incidence of trail damage and necessary repairs will also be expected to increase.
And that is going to bring us to our 8 o'clock time here. Now, if anyone, there were several questions that we couldn't get to. So just thank you for sending those to us. And now I see Casey's, he's drops our web pages in the chat here again, and you can find my contact information on there as well. Should you choose to have any additional comments or question that you would like to share to me, I would be happy to have some further discussions with you on those. But with that, I would really like to thank Smith Group and Dave and Craig. Thank you guys so much for this presentation tonight. It's, yeah, we're on the right track, but we got a long ways to go.
Yeah. Well, thanks, Leah. Thanks for the opportunity. This has been we've had a great time working with the Friends of the La Crosse River. I don't know if I've ever worked on a project with as intelligent and engaged of a stakeholder group. So it's been real pleasant.
All right. Well, thank you everyone, and have a great rest of your night. Take care.